All right, welcome back. I've put together a few questions about arithmetic sequences. I think there's got to be 5 questions in this video. Make sure you pause the video before you practice them. There's no theory here. If you haven't checked out the theory part, plus some examples actually, not just theory, make sure you check out the video that I will tag here and then come back to it. Then you will get the most out of it. All right, so let's get to the questions. I put the formula booklet here. I mean a screenshot from the formula booklet, so we get comfortable with working with the formulas, which I also did in the other video as well. So in the arithmetic sequence, U4 is equal to 12 and U11 is equal to 9. By the way, I'll go a bit faster this time because I'm assuming you've watched the other video, so I don't need to go as slow. In an arithmetic sequence, U4 is 12 and U11 is -9. Find the common difference. So if U4 is 12, by using the formula we can say 12 is equal to U1, we don't know, n minus 1d, which will be 3 times d. This is for U4, okay, U4. U11 is going to be -9, that's going to be equal to U1 plus 11 minus 1 is 10d. So hopefully you can see that now we end up with a simultaneous equation. There's 2 variables and 2 equations. So we can do elimination method. I can subtract first equation from second or second first, doesn't matter. Let's subtract second one from the first one. That's going to give me 12 minus -9. And here I will get U1s will cancel out, 3d minus 10d. This is going to be 20, not 20, 21. And that's going to be -7d. And from here we can say that d is equal to -3. Okay, so the common difference is going to be -3. Find the first term. Now that we have found, let me put a here. Now that we have found a d, we can plug it into any of the 2 equations and we can find out what U1 is. I'm going to stick with the first one because it's 3d, not 10d, so multiplication might be a bit simple. So 12 is equal to U1 plus 3 times -3, which is -9, so U1 minus 9. And from here U1 is going to be equal to, again, 12 plus 9, which is 21. So U1 is going to be 21. And lastly, C. Find the sum of first 11 terms in the sequence. First 11 terms. Now we have 2 equations for the sum. I talked a lot about it on the other video. Again, I will not go into too much detail. Since I don't have the UN, which is U11, what I will do is I will go with the first formula, which what I mean by that is this one. Okay, I know my U1, I know my D, and I know my N. So there's nothing really stopping me to find S11 is going to be equal to 11 divided by 2. 2 times U1, which is 21, plus N is 11. 11 minus 1 is 10. 10 times, and D is -3. Okay? That's all. So I'm going to leave 11 over 2 because it's not a good division. Maybe something in the bracket will make it easier. And this is going to be 42 minus 30. Yes, that sounds all right. And that is going to be equal to, again, 11 over 2 times 12. Okay, good. 12 and 2 will cancel out. So 11 times 6, and that's going to be 66. So the answer for C is going to be 66. An arithmetic progression has a common difference of d, where d is different than 0. The 7th term is equal to the 3rd term squared, and the 5th term is 1. Find the common difference. All right. So, a bit more confusing than the previous one, right? But again, all we have to remember when it comes to sequences and series, both arithmetic and geometric, is everything is around these 2 formulas. For geometric, there is also infinite sum, but we have UN and SN for arithmetic. That's it. They can ask it in a weird way. It doesn't matter, right? We only have two formulas. Every time you write it down, something will happen, even if it's not clear from the beginning. All right? So let's see. It says U7 is equal to third term squared. So let's try to represent that algebraically. So U7 is equal to U3 squared. Okay, and we also know that U5 and the fifth term is 1. Okay, so let's see what we can do from the first equation. I'll put A here because this is going to be find a common difference attempt. So what is U7? Again, I'm using my formula. U1 plus 6D equals to U3 is U1 plus 2D squared, right? Cool. Now let's simplify. U1 plus 6D is equal to U1 square plus 4U1D and what else? Plus 4D squared. Okay, let's move things around and see what we have. Or maybe we can try something else. Can we try something else? I don't know. So let's try this one. U5 is U1 plus 4D is equal. I'm just writing that in case we might need it. In case we might need it. So this one seems all right. U1 plus 6D, we can keep that as it is. From here, I feel like we can take U1, factor out U1 from the first two expressions. That's going to give us U1 plus 4D plus 4D squared. Okay, since we know this is equal to 1, that's a very good substitution to make. So U1 plus 6D is going to be equal to U1 times 1, because U5 is 1, so this is 1, plus 4D squared. Okay, then what else we can do? U1s will cancel out, right? So we're left with 4D squared minus 6D is equal to 0, right? From here, we can potentially find out what our D is. So I'm going to factor out 2D here, 2D, and that's going to give me 2D inside minus 3 equal to 0. Now, this equation has two answers. One of them is D equal to 0, but that's not good because the question says D is different than 0. And the other one is going to be 3 over 2, but that's good. Now let's take a look at question part B. Sn is the sum of the first n terms of the sequence. Find the largest value of n such that Sn is less than 300. Now, again, this is a bit more complicated than the questions that we did in the first video. But again, like I said, we use our formula. So Sn, we don't know what n is, but we know what our d is. Now, if we know our d, we can actually go ahead and find our u1 from the fact that u5 is equal to 1. So u5 is equal to u1 plus 4d, which I wrote at the top. And that's equal to 1. So we can say u1 plus 4 times 3 over 2 equals to 1. And then u1 is going to be equal to what? 1 minus 6, and that's going to be negative 5. Yes, so u1 is going to be negative 5. Now I can write my Sn formula. So Sn is going to be equal to n over 2, because I don't know what my n is yet, 2u1, that's negative 10, plus n minus 1, and 3 over 2. Right? So far so good. I'm going to keep the n over 2, negative 10, plus 3 over 2n minus 3 over 2. Okay? Now, at this point, we know that this sum needs to be less than 300. So what we can do, we can go two ways. We can expand the bracket, and as you can imagine, there's going to be a quadratic function if we do that with n squared, right? Or we can use a GDC to produce a table values for Sn. Okay? If you have a GDC and you know how to do that, go ahead and do that. And I will give you the table now. So here's the table. You can see that for potential values of n, different values of Sn, and you can see that at some point it surpasses the 300. So 24 is 294 and 25 is 325. So we're looking for the largest value possible for n, that's less than 300, and that's going to be 24. So the answer for this one is going to be 24. The fourth term arithmetic sequence is equal to 13, and the sum of the first 10 terms is equal to 55. Find the common difference. All right, let's use our formulas. The fourth term is equal to 13, so I will say U4 is equal to U1. Get used to writing that. 3D equal to 13. And the sum of first 10 terms, so S10 equal to 10 over 2. And what do we have here? 2u1, because we don't know what u1 is. N minus 1 is going to be 10 minus 1. 9d is going to be equal to 55. Let's make this a bit more pretty. 10 divided by 2 is going to be 5. And if I divide both sides by 5, I'm going to have 2u1 plus 9d is equal to 55 divided by 5, which is 11. So what do I have here? I have two equations. Equation 1, equation 2. Can I do simultaneous equation? Absolutely. What can we do? We can do substitution here, although I don't like it very much. But let's try it. So u1 is equal to 13 minus 3d. And let's use that u1 in this second equation. So 2 times 13 minus 3d is going to be plus 9d has to be equal to 11. And then let's open the brackets there. Am I missing a bracket here? Yes, I do. 26 minus 6d plus 9d is going to be 11. 3d is going to be equal to negative 15, and d is going to be equal to negative 5. Okay, so part A is done. This is negative 5. Now the part B, determine the greatest value of n such that nth term is positive. So let me put A here. And now we can take a look at B. Again, determine the greatest value of n such that the nth term is positive. What does that mean? It means nth term is what? u1 plus n minus 1 d, right? That's nth term. And it says it has to be positive. So I'm looking for solution to this inequality. Now, in the previous one, I found my d, which is negative 5, which also means I can find my u1, actually. Let's complete that. I know they're not looking for u1 in the part A, but we can go back to the substitution we did and plug in negative 5. So 13 minus 3 times negative 5, and that's going to be equal to 28. So now I have 28 plus n minus 1 times negative 5 greater than 0. Let's open the bracket. 28 minus 5n plus 5 has to be greater than 0. And you'll see negative 5n greater than, I want to say 33. And we have to divide both sides by negative 5. And when we do that in inequality, we have to change the sign. Let's not forget that. N less than 33 divided by 5. So that's our answer. But it says determine the greatest value of n such that the nth term is positive. Since n has to be an integer, the greatest term we have is going to be the integer part of it. So this is equal to 6 point something. But we don't care about the something, so 6 is what we need. because we need an integer value. In an arithmetic sequence, the third term, u3, is equal to 41. The ninth term, u9, is equal to 23. Find the common difference. Again, we've done that before, so a u1 plus 2d is equal to 41. u1 plus 8d is going to be equal to 23. Now I can use, what can I do here? I can do substitution or elimination. I like the elimination better, so I'm going to subtract first equation from the second one, or the other way around, doesn't matter. Let's do first from the second, so we don't have an, well, we'll still have a negative number. Anyways, let's do that. Subtract. u1 will cancel. Negative 60 is going to be equal to 41 minus 23, which I believe is 18. And d is going to be equal to negative 3. Cool? Once we find d, so common difference, negative 3. The next question is find the first term. That part is easy because now I can plug it into any of the equation. Let's pick first one, for example. So negative 3 plus, no, not negative 3. u1 plus 2 times negative 3 has to be equal to 41. That means u1 has to be equal to 41 plus 6, which is 47. So that's B. That's B. Now C. So B was 47. Find the smallest value of n such that Sn is less than 0. So what is the formula for Sn? Sn is equal to n divided by 2. We're going to keep that. 2u1, we know u1 is 47, so 2 times 47 plus n minus 1 times negative 3, right? And that's it. Did I close all the brackets? I think I did. And that has to be less than 0. So basically we have to solve that equation. So again, n over 2, let's keep that. 2 times 47, what is that? 94 plus, not plus, minus 3n. I'm opening this bracket. Plus 3. And that's equal to, oh, not equal to, has to be less than 0. Again, n over 2 and 97 minus 3n has to be less than 0. Okay, so n says the first solution to that will be n less than 0, which we cannot have, right? N has to be an integer. But the second one will be 97 minus 3n less than 0, which means 3n is going to be greater than 97, and n is going to be greater than 97 divided by 3. So whatever that is, 32 point something. Okay, now what are we looking for here? We're looking for integer value, and n has to be greater than 32.33. So the next available integer value will be n equal to 33. So at 32, it's going to be positive. After that, after 32.33, it's going to become negative. So the next available integer is going to be 33. So n is equal to 33. The seventh term of an arithmetic sequence is equal to 1. So this is arithmetic sequence u7 equal to u1 plus 6d equals to 1. And the sum of the first 16 terms, so S16, is equal to what? 16 divided by 2, oh no, not u1, 2u1 plus 16 minus 1 is 15d, has to be equal to 52. Find the common difference and the first term. So we're looking for d and we're looking for u1. Okay, so let's see what we have. Again, we're going to have a simultaneous equation case. So equation 1 is u1 plus 6d equals to 1. Equation 2 is going to be, so let's simplify this a bit, 8 2u1 plus 15d equals to 52. And 52 is not divisible by 8. Okay, we'll leave it like that then. So 2u1 plus 15d is going to be equal to what? 52 divided by 8. Yes? Now, what can we do here? What can we do here? We can probably simplify this to 26 and 4. Further simplify 13 and 2. Okay, so this equation can become, multiply both sides by 2, 4u1 plus 30d equals to 52. Oh, not 52, 13, sorry. 13. Cool? So we've got that, and so we've got this equation and this equation. Try to use elimination method, but to do that I might need to multiply my first equation by something. So let's do it by 4. So 4u1 plus 24d is going to be equal to 4, and this is the second equation, equals to 13. If I subtract first one from the second one, I'm going to have 6d, so u1s will cancel out. The second terms will give me 6d equal to 13 minus 4, which is 9. And d is going to be equal to 9 over 6, which is also 3 over 2, 1.5. So d is 1.5. And now we can find u1 just by substituting it back to one of the equations. First one seems simple. Let's do that. So u1 plus 6d has to be equal to 1. Now we say u1 plus 6 times 1.5, no need for bracket, 6 times 1.5 equals to 1. u1 will be equal to 1 minus 6 times 1.5, I think is 9. That's going to be negative 8. So negative 8 is going to be our, what? u1. There you go. I hope you guys enjoyed this session. I think we did 5 problems. Make sure you pause the videos before each question and then go through your own solution and then check out mine, because they can give you like a different perspective on how you can also solve a problem. Doesn't mean this is the only way, and maybe your way is better, but doesn't matter. Whichever one is more efficient, whichever one gets you to the correct answer is the one you should be looking for. That being said, that concludes my what I wanted to talk about for arithmetic sequence for now, and I will see you guys in the next one.